Hello and welcome to this video where the title is Access, Download and Pre-Processing of the INTAROS OBS data. This video was created by me, Peter Voss. I'm from the Geological Survey of Denmark and Greenland. We are located in Copenhagen. And my colleague Mathilde Sorensen, she's a professor at the University of Bergen. We both work in the field of seismology. This video will show how you get your hands on the OBS data that we installed during the INTAROS project, and a little bit about how to handle them when you have them on your computer system. Of course, we did not do this work alone. We did it with a lot of our colleagues, and I'll just show you the names of those later on in this video. This video is one in three. There's another video by Christian Ronnevig, also from University of Bergen, where he presents how you access the earthquake catalog that we constructed during the INTAROS project. And there will be an additional video follow-up to this one where you can see some examples on how you do analyzing of seismic events recorded by these OBS instruments that we deployed during the INTAROS project. So first of all, OBS means ocean bottom seismometers, so they were deployed on the sea floor, and there was 3 of them, and they recorded some earthquakes between Svalbard and Greenland for a period of time. So I'll just show you how to get access to these data. But let's first see how that works. The data from the stations are in a system called IDA, so that's a European Integrated Data Archive, and there's a node at University of Bergen, so this is what it looks like, just to get you an idea of what IDA is. IDA is part of ORFEUS, the European cooperation on observatories and research facilities for European seismology. So that's in the European and Mediterranean area, where the cooperation is done mainly on broadband seismology, but also in other areas of seismology. And IDA is the branch for sharing data, and it's a European Integrated Data Archive infrastructure within ORFEUS. And just to give you an idea, I'll go here on the ORFEUS website. There's a link to IDA data access, and you will see on the map here, you will see all the stations in the European Mediterranean area. And if you check out the operational and closed stations, you will see a number of nodes, and these are the IDA nodes from where you can access data. And ORFEUS data are accessible through the IDA node at the University of Bergen. So first of all, if you want to access data, there's different ways to decide what kind of data you want and when the data are there. You can, for example, go to the EMC website, and then you can see if there was earthquakes in the region or in the time before you go access the data. You can also have a look at the ISC to see if they have data that you want. But as I said, we also did in the INTAROS project construct a catalog for the Arctic region, and you will find it on the INTAROS web page. You will find on the news site there's a guided tour to the INTAROS data catalog with respect to these earthquake data that we have collected. And Christian Ronnevig also already made a video, and you can access the video through YouTube. It's called INTAROS Data Catalog Demo. So for this, I'll just give you a brief overview how to first of all access the data. So you have to enter this IDA node from the University of Bergen, and when you go there, it looks like this. You can
it says you can explore events. So if you already know that there are maybe a significant earthquake in the area or an earthquake in the system, it's easy, you can then explore it. But for this presentation, we'll just use the option of exploring stations. So we'll say we want to explore stations, and for the OBS stations, first of all we need to check down the interval that we want, so 2017 to 2000 and let's just say 19 or here for example, and then you can there's different options here, but for our case we want to search by region, and when you do that you will maybe here say 74 north to 90 north, and then you might say 18 east to 11 18 west to 11 east, and then you will see at the same time on the map this area will be mapped out. You can still zoom out, and then you can see it's highlighted where in what area you will search for instruments that or for stations that were located in the time interval you already defined up here. So next thing is I will say I want to search for this in this area, and here it lists all the instruments that are in the system at that time window. So what you'll see here, there's 3 stations deployed, and you will see where they are located on the map, and the station code, they all have a network code. There's some metadata on the location from the station here. Of course, if you delete these stations and then you expand your area, we now go to 18 east and we say search, you will see where you will get additional stations out here on Svalbard, but that was not what we were looking for here. So we'll go back, we'll delete the stations in the lists, change the area, and we'll try to search again. So this is now the area that we want, and these are the stations that we want to download some data from. So the next thing is I'll say save these stations here, because then it will give me a comma separated file if I want that with some of the metadata for the stations. So that's like long, but that's not for this video. So that was one option here. But what we really want to do is we want to download data. So first we need to submit a request. So we select submit request, and now we can actually define a time window from where we want data from these 3 stations that are lined up of the entire stations that we see down here. And in this case, I know there was an event 2018, so I'll just check out that small event 2018 like this. As you see here, you can actually click the date, but you can also just type it in, and it's in the middle of the night, so you just say here, and I just want 10 minutes for this example, and you can see it's already there because I did the test before. And in this case we want the waveform data, so we'll select the mini-seed data, but you can also get the metadata in XML format or the metadata in text format if that's what we want. But for now, we just, in this example, we just want to see the waveform data. I can then just hit the submit, and what you see up here is now there's a download tab that starts blinking, and it means that the system is processing the request. There's also a console that you can see here where you can see what's going on in the server, that it's processing the data. So we'll go to download here, and now you see, oh, it's already ready for us. There's data package here, so you can actually say, okay, I have my data, it's ready for me, I can save the data on my system. So basically just save these data, you click save, and then the browser will download the data file for you on your system. So this will work as long as you have a browser on your computer, and it should all be fine. So that was how to access and download the data. Now I'll just show you
just a brief overview of an example of on how to pre-process the data, and for that I'll jump into my Unix system here. So this in this folder I have downloaded the file, and it was in this mini-seed format, and I have a README file just to help me show the examples of pre-processing I want to do. So first of all, I want to use this data select software. So this is software from IRIS in North America, then that helps you split the file up into this SDS. So this is a seismological data structure. It's very useful for many kind of softwares to use this structure. It means that the mini-seed file will be split up in folders for year, network code, station code, channel code, and then files that follow the same example. So I'll just execute that line, and now you should see that I have a folder now called SDS, and if I say find to SDS, I will see that this mini-seed file is now split into several files for each of the stations. So of course for this one it has 4 files for each station. Here you see there's a HDH channel, and that's the hydrophone of the OBS instruments. Then there's a 1, so that's, and 1 and 2 are the horizontal components of the seismometer. And then there's the Z is the vertical component by the seismometer. So just to show the data, I'll now cat this one of the horizontals, the HD2, into a data file. I'll do like this. Since in mini-seed you can just cat one file after the other. And now I have a file called data.miniseed, and I can use another IRIS software called MSI to see what's inside the file, and it will list the time window that I find in the file and how many samples there are. I can also do plotting, and for this I'll use the SEISAN software, and SEISAN software has a program called moveplot, and there I just need to say what the data file name is, like this, and I need to move the window so that you can see. I get an option on what I want to see. I just say okay, I want to see all this data, and I'm sorry the window is maybe a little bit small, but there you will see this is the data that I requested, and I can apply some filters, and then I can see, okay, it seems there is some kind of event here. I can maybe even add the spectrum to that, and yes, there was a event, probably PNS waves on this system. So that was just a very short introduction to how to access and download the data from the INTAROS OBS ocean bottom seismometers through this IDA system. And in the following video we'll show you how to do some analyzing of these seismic events. If you're not so familiar with all this, we recommend you to look at the different kind of software that we have used from the IRIS web page, but also there's the SEISAN manual has some good examples on how to access these data. But that's all, and thanks a lot and good luck.